The control man continues to turn the speed controller counterclockwise to bring the shaft revolutions to the right number for 1/3 astern. When the speed controller is set for astern and an order to go ahead is received, the wrong direction light and bell are energized when the order is answered and continue until the speed controller comes to the off position. Avoid turning the speed controller too fast. This is to keep the propulsion loop current, as shown on the loop ammeter, from exceeding its rated value. Running above the rated value overloads the engines, generators, and motors. The speed called for on the engine revolution telegraph may be intermediate between two successive positions on the speed controller. The control man sets the speed controller to a position close to the speed called for. He then makes the small speed adjustment with the motor field controller. The engine revolution indicators show that number 3 engine is running faster than number 4, taking more than its share of the load. To bring the engines to the same speed and to equalize the load between them, turn the vernier governor transmitters to decrease the speed and load of the fast engine and to increase the speed and load of the slow engine. At any time the engines are not running at the same speed, balance them with the vernier transmitters. The control man must have a thorough knowledge of the propulsion group and the control board to get ready to run. Actual operation, when no trouble develops, is very simple. The speed controller has primary control over the speed of the shaft. Turning it alone will vary the speed of the shaft from full astern to full speed ahead. The motor field controller is not primarily for the control of speed. Its primary use is to set the motor field current for 1 or 2 generator operation. Its secondary use is to make very fine speed adjustments. Intelligent use of the speed controller and the motor field controller will hold the shaft revolutions called for. Tests and inspections underway. There are various tests and inspections to be made while underway. Every hour, readings are taken to be recorded in the engine room logbook. Right on the hour, the counter of the shaft revolution indicator is read. All instruments are closely watched for the indications they furnish on the performance of the electrical propulsion equipment. Both generator voltmeters are read and their voltage is recorded. The loop ammeter is read and recorded. The voltage applied to each of the propulsion motors is measured by turning the motor voltmeter and ground detector switch to motor 3 and motor 4 position. Once each watch, it is advisable to check for grounds in the propulsion loop circuit. When the voltmeter shows only a momentary deflection, there are no low resistance grounds. The motor field ammeter is also read. The exciter voltage is read with the exciter voltmeter switch at control bus, and the switch is then turned to motor field and generator field to read the voltage. Another test for grounds on the exciter circuits is advisable at least once a watch. Some of these circuits were tested before getting underway, but some were not energized at that time. A complete check can now be made by turning the ground detector switch to each of its 6 positions. A small reading indicates freedom from grounds. A large reading would indicate a low resistance ground. Readings must also be taken and recorded showing the air temperatures to and from the air cooler for each motor. When the inlet air temperature rises above its proper value, it indicates that the motors are not being sufficiently cooled. The inlet cooling water valves for the motor air cooler should be opened more. This completes the tests and inspections on the upper level. At the same hourly interval, tests and inspections are also made on the lower level of the motor room. These include temperatures, pressures, and adjustments. The lubricating oil pump is inspected for leakage and correct pressure. Lubricating oil flow is noted along the outboard side of the propulsion motors. At the forward end of the number 3 motor, the interior should be inspected for excessive sparking and to make reasonably sure that everything is operating smoothly. Record the reading of the motor bearing thermometer. Between the number 3 and 4 motors, both general condition and thermometer temperatures are noted. At the after end of the number 4 motor, the bearing thermometer is read, and on the inboard side of the thrust bearing, pull out the dipstick to see that the oil level in the reservoir is correct. Look at the gauges on the saltwater circulating system, and if they do not register the proper pressure, readjust the bypass valve. Look at the packing gland on the pump. There should be a little leakage, just enough to lubricate the packing. Near the center line and forward, read the bearing temperature and check oil flow on the forward end of the number 4 generator. Also the inlet and outlet air temperatures on the generator air coolers. At each generator bearing, inspect the oil flowing through the sight glass. At all generator speeds, this flow of oil is very important. Inspect the interior of the generator to see that everything is operating smoothly. Running between the number 3 and number 4 generators is the starboard propeller shaft. At intervals along this shaft, there are bearings. Lift up the 2 inspection plates to see that the oil rings are turning and distributing lubricating oil properly. At the after end of the number 3 generator, check the flow of oil to the bearing. Thermometer readings are taken. The inlet and outlet air temperatures on the generator air coolers are read on the outboard side of the generator. The possibility of having to readjust cooling water flow to maintain proper temperature should be kept in mind. When any such adjustment is necessary, regulate the inlet cooling water valve at once. This completes the hourly tests and inspections on both the upper and lower levels of the after motor room. All readings are entered in the log by the control man and the oiler. Securing. When the DE comes into dock or is moored after being at sea, the signal for stop comes down on the engine order telegraph. The control man turns the speed controller to off. This removes the field from the propulsion generators and permits no large amount of current to flow. Residual magnetism in the generators may produce sufficient current to keep the shaft turning slowly, as shown by the shaft revolution indicator. When this happens, the speed controller is turned in the opposite direction until the shaft comes to a complete stop. The speed controller is then turned to off. The control man stands by awaiting further orders. When the order to secure is given, the talker notifies the control man. The control man pulls out both the main field and the main governor control cutout switches. At the generator section, the two generator transfer switches are put into the bypass position. Press down the latch lever before turning. Both individual governor control cutout switches are turned to the off position. The engine room signal board on the port side of the control board transmits the order to the after engine room to stop both number 3 and number 4 diesel engines. After giving the stop signal, the control man watches the readings of the two engine RPM indicators. The drop in the RPM indicates that the order has been carried out. The engine signal switches are turned to off. The lubricating oil low pressure alarm is turned off. And while holding down the latch, the exciter transfer switch is turned to off. The control man then steps over to the power panel and turns on the propulsion motor space heaters. These warm the inside of the motor enclosure and prevent condensation of moisture on the windings. At the IC panel, the lubricating oil low pressure and throttle position indicator switches are turned to off. On the lower level, when the order to secure is given, the oiler stops the saltwater circulating pump and proceeds to close all valves in the system. The main suction valve, the individual suction valve to the pump that has been in use, the discharge valve from the pump to the main machinery. Closing all valves is the reverse of making ready for propulsion. The bypass valve is closed, and the distribution valve to the motor and generator coolers. The oiler has to know all of his systems thoroughly to be able to operate his equipment properly. On the outboard side of the number 3 generator, the oiler closes the overboard discharge valve for the generator air coolers, then turns on the space heater for the number 3 generator. In between the generators, the outlet and inlet cooling water valves for the number 4 generator are both shut off. The space heater for the number 4 generator is turned on. That is all that can be done on the lower level in securing the generators. Forward of the number 3 propulsion motor, the valve supplying water to the stern tube gland is closed. Working aft, the discharge valves on the motor air cooling system are turned off. The lubricating oil pump is stopped, and all valves in the system are closed. These include the suction, discharge, and the bypass valve. The overboard discharge valve for the propulsion motor cooling system is shut off. Then the oil inlet and outlet valves for the lubricating oil cooler. Also the lube oil distribution valve to the thrust bearing. This completes the work of securing on the lower level. On the upper level of the after motor room, the inlet valves for the cooling water to the propulsion motors are closed. In the procedure of securing, it is best to follow a regular routine. In this way, you will know that everything has been secured. On the starboard side of the upper level, both the outlet and inlet cooling water valves for the number 3 generator are turned off. And that's all to securing. And that's all to the normal operation of the diesel electric destroyer escort using full propulsion equipment.